So, have you ever stopped and wondered how an AI can just suddenly interact with your code, or your database, or even your team's Slack channels? Well, there's this really powerful kind of behind the scenes protocol making it all happen, and it's called MCP, which stands for the Model Context Protocol. Let's just dive right in and demystify what might be one of the most important standards in this new age of AI.
Okay, to really get our heads around this, we need a simple analogy. And honestly, the best one out there is this. Think of MCP as being like a USB-C port, but for AI. You know how USB-Cs saved us from that tangled mess of a million different chargers? It gave us one universal standard. Well, MCP is doing the exact same thing for how AI models connect to, well, everything else. It is a total game changer.
All right, so here's how we're going to break it all down. First, we'll stick with that core USB-C idea. Then, we'll get into the huge problem it solves. After that, we'll see how it all connects, what the building blocks are, watch it in action, and finally, take a look at what this all means for the future.
So, yeah, let's kick things off with that central idea: one standard to connect them all. You know, before MCP, trying to connect an AI to a tool was, well, it was chaos. Imagine you want your AI to talk to your database, your calendar, and your project management app. That meant building 3 separate, totally custom, and super fragile integrations. It was literally like having a different proprietary charger for every single device you own. A total mess. MCP just sweeps all that away and replaces it with a single, elegant protocol. One standard, one way to connect, and suddenly infinite possibilities. But to really, truly appreciate how great the solution is, we've got to understand the sheer scale of the problem it was designed to fix. And we call this the integration nightmare. And at the heart of that nightmare is this concept, the N by M problem. It's a classic scaling issue that's been around forever. So let's say you have, 10 AI applications. That's your N. And you want them all to connect to 100 different tools. That's your M. Well, without a standard, you'd need to build and maintain N times M integrations. That's 1,000 unique connections. It's this combinatorial explosion that makes building powerful AI systems so incredibly difficult and expensive.
And believe me, it gets so much worse. As the number of AIs and tools grows into the thousands, you're suddenly looking at millions of potential connections. It's not just that it's hard to build, it's an absolute nightmare to maintain. Every single time an API changes, something breaks. MCP was basically born out of the desperate need for a simpler, more scalable way to do things.
So, how does MCP actually solve this mess? It uses this beautifully simple and incredibly effective client-server architecture. Let's take a look at the key players involved.
Right, there are 3 main components here. First up, you've got the host. Just think of it as the brain. This is your main AI application, maybe an AI-powered code editor or something. Then you have the server, and this is the specialist. It's a small, very focused program that knows how to do one thing really, really well, like talk to the GitHub API. And finally, you have the most crucial piece, the client. It's the translator. This is the universal interpreter that lives inside the host, and it speaks the MCP language. This is what allows the brain to talk to any specialist without needing to learn all their different native languages.
And this is how it all flows. And this is key. The host, our AI brain, never, ever talks directly to the server. Instead, it has a high-level goal, something simple like find recent commits. It just hands this goal off to its translator, the client. The client then converts this into a standardized MCP message and sends it over to the GitHub server. The server does its thing, gets the commits, and sends back a standardized MCP response. The client then translates that back for the host. You see? This layer of translation is what makes the whole system just work.
So here's a really crucial point to remember. The connection is always one-to-one. A single client can only talk to a single server. So if your AI host needs to talk to GitHub and Slack and a database, it's actually going to have 3 separate clients running inside of it, one for each of those specialist servers. This is what keeps all the communication clean and really well organized.
Okay, so we know servers are these specialists, right? But what can they actually do? What can they offer to the AI? What are the actual building blocks of this new language?
Well, a server can offer 3 fundamental things to an AI host. It can provide tools, which are basically actions. It can offer up resources, which represent knowledge. And it can share prompts, which are kind of like recipes for getting things done right.
Let's break those down.
So
Tools are the verbs. They're the actions the AI can ask a server to do. Things like create GitHub issue or search database. Then you've got resources, which are the nouns. This is static knowledge the AI can read and reference. It could be a project's README file for context, or a database schema so the AI understands the structure of the data. And finally, prompts. Prompts are basically recipes. They're predefined templates that guide the AI on how to use the tools and resources correctly, making sure, for instance, that it formats a bug report perfectly every single time.
All right, this is where it all comes together. Let's see how an AI host can actually orchestrate multiple different servers to handle a pretty complex request. So imagine you ask your AI assistant something like, hey, summarize the recent activity in my project repo and post it to our team's Slack channel. The host agent, our AI brain, immediately realizes this is a two-part task. First, it uses its GitHub client to call the GitHub get commits tool. It gets that data back, uses its own intelligence to write up a quick summary, and then it uses its Slack client to call the Slack post message tool. You see, two different specialists, all orchestrated by one brain to complete a single goal. That's the real magic of MCP. And that little workflow actually highlights some key best practices. Did you notice the tool names are prefixed, like GitHub _ and Slack _? That's really important. It prevents confusion if both servers had a generic tool just called post. The servers are also kept lean. They do one job well with just a few tools, which keeps the context clear for the AI. And finally, the tools are named for their intent, what they actually achieve, not all the technical low-level steps involved.
So, you can see this isn't just about connecting one AI to one tool. This is about building a completely new kind of AI ecosystem.
MCP is really the foundational language for the future of AI. It's what's going to enable these incredibly complex multi-agent systems where you have swarms of specialized AIs, each with their own set of tools, all collaborating to solve problems that are way beyond the scope of any single model. It's the beginning of a truly composable, cooperative AI.
And that leaves us with a final, pretty powerful question to think about. We've just seen how a universal standard like this can unlock some incredible potential. So if every app, every database, and every service in the entire world could speak the same AI language, what could we build? What huge, seemingly impossible problems could we finally solve? That's the future that MCP is building toward.